Good morning, my students. We are going to solve some problems about alternating current circuits. If you have a inductance 7/220 Henry and the ohmic resistance 40 ohm connected in series with a capacitor of capacitive reactance XC equal 5 ohm and the variable ohmic resistance are connected with 10 ampere alternating current source of EMF 13 volt and the frequency 50 hertz. If the current intensity passing through the coil must exceed than 1 ampere, not more than 1 ampere, calculate the minimum value of the ohmic resistance that is connected in series to the circuit can be safely be used in this circuit, neglecting internal resistance of the circuit. At first, we have the value of self-induction, by which we can determine the value of XL equal to by FL. 2 times 22/7 times the frequency equal 50 hertz times L equal 7/220. At first, we calculate the inductive reactance. We know the meaning of capacitive reactance. EMF epsilon effective equal IZ. EMF effective equal 13 volt. Current intensity equal 10 ampere equal 10 ampere. Z equal 13 divided 10 ohm. We need to calculate the minimum value of the resistance. Z is called impedance equal root R squared plus XL minus XC all squared. By knowing the value of the impedance from this relation and the value of the RXL inductive reactance, which we can calculate it from this relation X equal to by FL, and in the capacitive reactance given equal 5, we can calculate the unknown value of the resistance. Okay? Another question. In the opposite figure, AC circuit contains two components X and Y, two different components, X and Y. The graph shows the change in Vx and Vy with time. Determine the type of each component. At first, at this point, we observe that Vy is maximum. And the A circuit, VL leads I by 90. This is the difference between them equal 90, angle equal 90. This means that if this Vy is L. And R is called X. And X is called R. This is the first. Calculate the phase angle. The phase angle equal tan theta. Tan theta equal VL over VR, 8/5. From this, we can determine the value of theta equal 53 degree. Impedance of the circuit. Impedance of the circuit Z equal V effective over I effective equal 2.5. A coil of inductance 0.0 Henry, this is the value, L, is connected with a capacitor of capacitance 5 microfarad times 10 power negative 6 to convert it from microfarad to farad. Connected in series with alternating generator of 30 volt. This means that alternating current, the EMF is effective value. At this 400 hertz is the frequency. And the ohmic resistance 90. Find the inductive reactance XL, inductive reactance, and the capacitive reactance XC of the capacitor. XL equal 2 by FL. 2 by 22/7 times F 400 times L equal 0.06. The answer is 150.86 ohm. This is the answer. Calculate the capacity of the capacitor. The capacity of the capacitor XC equal 1/2 by FC. Pi equal 22/7, F equal 400 hertz. Capacity equal 5 microfarad times 10 power negative 6 to convert it into farad. The answer equals 79.55 ohm. Number B, find the impedance Z. Z equal root R squared plus XL minus XC, all of them squared. R squared equal 90. XL equal 150. XC 79.5. From it we can determine the value of Z, which equal 114.83 ohm. Find the intensity of the current. V effective equal I effective Z. V effective equal 30. I effective, we need to determine it. I. Z equal 114.83. From this, we can determine the value of the current intensity, which is equal 0.26 ampere. Number D, phase angle between current and voltage. Phase angle equal tan theta equal XL minus XC divided R equal 38.39. Okay? Find the dissipated power. Dissipated power equal I squared R. R, the resistance 90. I squared, which he calculated from this. This is the end of the problem. Another problem. Number 39. Number 39. AC source of frequency 50 hertz. This is the frequency. Is connected in series with the inductor. Inductor means inductive coil of reactance XL. 318.18. Capacitor of capacitance 5 microfarad. This is the C capacity. And ohmic resistance 15 R. Calculate the phase angle between the current and the voltage and the current. To calculate the phase angle, we need to determine at first the value of XC. XC equal 1 over 2 pi FC equal 1 over 2 times 22 over 7 times frequency, in this case equal 50, times 5 times 10 power negative 6. Calculate at first the value of the capacitive reactance. Then find phase angle tan theta equal XL minus XC divided R. Number 2, the capacitance of the capacitor C2 that should be connected with the first capacitor to make the phase angle between voltage and the current is 0. This is the key of the problem. Phase angle equals 0 at resonance state. Determine the method of connection of the two capacitors. This means that the connection in resonant state. Resonant state. When the potential difference across the coil, by calculating VL equal IXL. VL equal IXL. When the iron core is belonged in a coil of self-induction 0.1, its self-inductance becomes, when we insert iron core, the magnetic permeability increases and concentrate high magnetic field, which is directly proportional with the self-inductance. This means that the self-inductance becomes greater than 0.1 Henry. And the next question, we observe that if the impedance of the circuit equal R, the self-induction coefficient equal in this circuit. In this circuit, the capacity of the capacitor 6 microfarad and 50 hertz. This is the frequency of it. In the illustrated circuit, if the impedance equal R, impedance Z equal R, this means that the circuit in resonant state and the XL equal XC. XC can be calculated from the following relation. XC 1 over 2 by FC. The frequency is 50. The capacity is 6 times 10 power negative 6. From this relation, we can calculate the value of XC, which equal the value of XL. When we need to determine the value of it, self-induction coefficient XL equal 2 by FL. XC equal XL. Calculated XC from this and put instead of XL. Then we find the value of L. And the opposite figure, the circuit AC source in the variable frequency F. And constant voltage. Then the voltage across the resistance R. This is the resistance R. Maximum value at frequency equal. Okay. A circuit shows AC source of variable frequency, constant voltage. The voltage across the resistance R reaches maximum. Voltage reaches maximum. The value of R is constant. The value of R is constant. The value of R is constant. VR equal IR. I is constant. R is constant. This means that I increases and the frequency is increased. This is the end question. Goodbye and good luck, my student.